An airplane, also known as an aeroplane in some countries, is a complex machine designed for controlled flight in the Earth's atmosphere. It works based on a set of fundamental principles of aerodynamics and propulsion. Here's a detailed explanation of how an airplane works. Aerodynamic principles. Lift. The primary force that enables an airplane to stay airborne is lift. Lift is generated by the wings of the airplane and is created due to the pressure difference between the upper and lower surfaces of the wings. This pressure difference is caused by the shape of the wing, which is designed with an airfoil profile, curved on top and flatter on the bottom. Drag. As an airplane moves forward, it encounters air resistance known as drag. Reducing drag is important to maintain efficient flight. Weight. Gravity pulls the airplane downward, creating a force known as weight. Lift must counteract the weight for the airplane to maintain level flight. Thrust. Thrust is the forward force produced by the aircraft's engines, which counteracts the drag and moves the airplane forward. Control surfaces. An airplane has three primary control surfaces to manage its orientation and direction. Ailerons, located on the wings. Ailerons control roll, allowing the airplane to bank or tilt. Elevators, located on the tail. Elevators control pitch, allowing the airplane to climb or descend. Rudder, also located on the tail. The rudder controls yaw, which changes the direction of the aircraft. Engines and propulsion. Most modern airplanes are powered by jet engines or propellers. Jet engines work on the principle of jet propulsion. They take in air, compress it, mix it with fuel, ignite it, and expel the exhaust gases at high speeds. This creates a forward thrust that propels the airplane. Propeller-driven airplanes have a rotating blade system that generates thrust by creating a pressure differential between the front and back surfaces of the blades. Phases of flight. Takeoff. During takeoff, the pilot increases engine power to create enough thrust to overcome drag. The airplane accelerates down the runway until it reaches a speed at which the lift generated by the wings exceeds the weight of the aircraft. This allows the airplane to become airborne. Cruise. In the cruise phase, the airplane maintains a relatively constant altitude and speed. It does so by balancing thrust and drag with lift and weight. The control surfaces, including ailerons, elevators, and rudder, are used to adjust the airplane's attitude and maintain its desired course. Climb and descent. When climbing, the pilot increases the pitch angle by adjusting the elevators to gain altitude. During descent, the pitch is decreased, and the airplane descends while maintaining controlled speed. Landing. During landing, the pilot reduces engine power and uses a combination of ailerons, elevators, and rudder to guide the aircraft safely to the runway. The objective is to reduce speed and descent rate gradually until the aircraft touches down. Navigation and communication. Modern airplanes are equipped with advanced avionics systems, including GPS, radio communication, and radar, to navigate, communicate with air traffic control, and avoid collisions. Safety measures. Aircraft are equipped with multiple safety systems, including redundant control systems, anti-icing systems, and emergency equipment to ensure safe operation. In summary, an airplane works by utilizing the principles of aerodynamics to create lift and generate thrust to overcome weight and drag. The pilot uses control surfaces to maneuver the aircraft and control its attitude, while advanced navigation and communication systems ensure safe and efficient flight.